All right, let's finish section 3.3 with an application of instantaneous rate of change. Okay, so I wanted to return to that distance velocity type of problem. So the distance in feet of an object from a starting point is given by s of t. So again, the s is usually a position function, okay? And given by this function here, where t is in seconds. So a good thing to keep track of is our answer for any kind of a velocity is going to be feet per second. Okay, so also keep in mind, this looks like a quadratic function to me, so this is just some kind of a parabola. And so it's certainly possible that depending on the moment that you choose or the interval that you choose, you could get a negative answer or a positive answer for the rate of change. Okay, and that just indicates direction, which direction it's moving. So remember, velocity considers not only how fast it's moving, but also which direction. That's all that it would mean for negative versus positive. So let's get going with part A and look very carefully. As soon as I'm doing these types of problems, I watch out for that word compared to this word. So average velocity, remember that that's going to be the average rate of change function. And that means that they need to give us two separate points. Okay, for instantaneous, we're going to do the whole limit process. Okay, so for average velocity, let's just work it out. Now it's f of b minus f of a over b minus a, but I'll make sure that I use the notation of s for the function. So it's going to be s of 4 minus s of 2 over 4 minus 2. So average rate of change. Okay, so let's plug these in. 2 times, plug it into the function, input squared minus 5 times input plus 40. Okay, so that's plugging in 4. Then we have to go minus plugging in 2. And I usually like to do a big parentheses right here to indicate that I might be subtracting by a lot of stuff. Okay, so plugging in 2, 2 times 2 squared minus 5 times 2 and plus 40. All over 4 minus 2 for 2. Okay, so I'll go ahead and just use the calculator for this, but if you were going to do this yourself, make sure that you follow the order of operations very specifically. A common mistake is to do 2 times 4 for an 8 and then square it, but that's wrong. It needs to be 4 squared first and then multiply by 2. Okay, the exponent comes first. So that's going to be 2 times 16 minus 20 and plus 40. And so that first number comes out 52. Okay, minus, okay, same thing, order of operations in there. So the 2 has to get squared first. So that'll be 2 times 4 minus 10 plus 40. So that's minus 38. Okay, so it looks like this is going to be a positive number answer. 52 divided by, or no, 52 minus 38. So we get 14 over 2. And so this is 7. And remember, we said the units are feet per second. Okay, average velocity over that interval. And again, I want to keep emphasizing that an average rate of change can be thought of as an average like slope. Okay, so rate of change can be thought of as slope. So for an average velocity, think about on the graph, and I'm going to say x, but the variable is t. But at an x value of 2, and you find the point that matches up on the graph at x is 2, and then you also find the point that matches up on the graph at x is 4, find those 2 points. If you worked out the slope between those 2 points and drew a line through it, that line would have a slope of 7. Okay, so yeah, good to keep that in mind, that the rate of change is really, you could think about that as a slope. So let's find the instantaneous velocity now. Okay, so instantaneous, that's the limit definition, and they do have to give us a single value here at t equals 4. Okay, so this is a t equals 4. I'll do both versions. So this alternative form, that's not the one that I use, but I'll show you how to use that one just in case you like it better. But the first one I'm going to use is the original one that we had here. So the limit as h goes to 0 of f of a plus h. And so this time we're using t equals 4. Okay, so we're going to have s of 4 plus h minus s of 4 over h. So let's write this all down. Instantaneous velocity, we're going to have the limit as h approaches 0 of s of 4 plus h minus s of 4 all over h. Okay, and this process is pretty long, so there's a lot of space here, but I'm going to use it all. So here we go. It's a little bit tricky. Make sure that you write the limit each time until you actually plug in 0. Now we could do the direct substitution right now, but you would end up with that 0 over 0 situation, that indeterminate form. So we got to work out this algebraically. So plugging in 4 plus h as the input. So be a little bit careful here. The function says 2 times input squared. So 2 times, and the input is 4 plus h. 4 plus h squared minus 5 times the input. And again, 4 plus h. Okay, and then plus 40. Okay, so that's the whole part just from s of 4 plus h. Now we go minus s of 4, and again, I like to use big parentheses to indicate there might be a lot of things we're subtracting right here. So s of 4, plug it in. 2 times 4 squared minus 5 times 4 plus 40. All over h. Okay, continue. Make sure you write limit again. Okay, and so let's see, let's go through and clean this up kind of piece by piece. First things first, this 4 plus h squared, that has to be written twice. So remember that if you square a binomial, you have to FOIL it out. So if you can do that in your head as just that perfect square binomial, go for it, but I'll go ahead and show a couple of those steps. I'll keep going and kind of clean stuff up piece by piece. So minus 5 times that 4 is going to be minus 20. Minus 5 times that h is going to be minus 5h. Okay, then there's that plus 40. Okay, minus, and then I think we already worked this out. 2 times 4 squared, yeah, we already did s of 4 earlier, and that came out 52. Okay, so yeah, we already did that one earlier. So all of that comes out 52. Don't really need parentheses, but that's what it all came out. All over h, okay, equals limit as h goes to 0. So again, here's where you got to FOIL this out. So leave the 2 outside and do 4 times 4 for 16. Okay, so just did that one. Okay, 4 times h is 4h. And then in the middle, another 4 times h. So that's plus 8h. And then in the back there, plus h squared. Okay, and then we can clean some of this up. Let's see, we've got minus 5h, but then there's a bunch of numbers and we can combine like terms there. So negative 20 plus 40 minus 52, that all comes out to minus 32. Okay, so kind of just piece by piece simplifying stuff. And the overall goal, and I want to kind of go back to what we did earlier, the overall goal, I have one of the problems here worked out. As we were working this all out, notice that there was some nice cancellation, and then at the end, we were able to factor out an h from the numerator and cancel it with that divide by 0 problem. So that's the goal. That's what we're hoping happens. Okay, so just keep that in mind. So let's continue. We haven't plugged in the limit yet, so keep writing limit as h goes to 0. Okay, so let's go through here and distribute that 2. So 2 times 16, we got 32 plus 16h plus 2h squared. Okay, then there's the minus 5h and the minus 32 all over h. And so I think everything is going correct because we've got this nice canceling right there. 32 and minus 32 is gone. So I'll go ahead and write this in like descending order. So the 2h squared. 16h and minus 5h are like terms. Those can combine for plus 11h. And hey, look at that. Both terms in the top have an h in common. So we can factor an h out. And exactly what we were hoping for is what happened. Now we have 2h plus 11, which that h can now cancel. And so we're almost done. One last time to write that limit. We have 2h plus 11. Now we can go ahead and use direct substitution. That's a nice polynomial. Remember, you can do direct substitution now. And so plug in 0 for h. We get 2 times 0 plus 11. That part goes away, and we get an answer of 11, and it's feet per second. All right. So to think about that, if you pick an x value or a t value of 4, and you look up and see where that matches on the graph, in that one instant, you can imagine that the slope of the function would have a slope of 11. Okay, so that's steeper. From 2 to 4, the slope was only 7, but right at 4, it looks like it got steeper. And that should make sense, because if you think about like the way parabolas look, if you did like a slope between 2 points right there, if you go farther along, it looks like the slope like kind of gets steeper as you go farther along. So that should make sense, and we're definitely going to talk about all kinds of ways that we analyze functions a little bit later. Okay, so that's the answer for the instantaneous rate of change. I'm going to do it again using that alternative form. Okay, so maybe you like this one better, so it depends. I'll go ahead and show you how we use this alternative form. Okay, we should get the same answer, all right? If it's the same, we should get the same answer. So in this previous one, we let h go to 0, and so there was an h involved all the way to the end. For this one, we're gonna let b approach a. So there's gonna be a b involved all the way to the end. So we want x to equal a. So for the alternative form, let me just write this. The alternative, and what should I call it? Alternative form, okay. Okay, so for this alternative form, we're gonna have x equals a. So the a value here is, I'll put it as t equals 4. And so what we want is the limit as b approaches 4. Okay, so we're gonna leave b alone, and then we're plugging in that 4 right there. So then we do f of b minus f of a. So s of the b, and so just the b goes in, s of b minus s of 4 divided by b minus a, so b minus 4. Okay, now notice if we tried to do direct substitution and we let b be, we plug in b is 4, then we get that divide by 0 situation. And so go ahead and just evaluate everything, and there should be some nice canceling, and hopefully we get that same answer of 11. Okay, so make sure you write limit each time. Limit as b goes to 4. Okay, so s of b, that just means plug in b. Okay, so the function is 2 times input squared minus 5 times input plus 40. Okay, so that's plugging in b. Okay, then minus the s of 4, and we already did that a lot. So s of 4, again, we've done that a few times. What was that? That was 52. Okay, I guess I'll write it out. It's going to be 2 times 4 squared minus 5 times 4 plus 40, all over b minus 4. Okay, equals limit as b approaches 4. So again, this stuff kind of just stays the same, 2b squared minus 5b plus 40, and then minus, okay, and then, yeah, this whole thing, the s of 4, you could work that all out again, but I think that was 52. Yeah, we did that a few times in the past. So that whole stuff comes out, excuse me, that whole stuff comes out 52. Okay, equals limit as b approaches 4. So on the top, let's clean that up. So 2b squared minus 5b, that can stay the same. Okay, and then we can combine 40 and minus 52. And so that's minus 12. Okay, and then here's where it's a little bit different than the h thing. In the h thing, we were able to cancel some like terms, cancel some things, combine like terms, factor out an h and cancel it. Here, we still want to do some factoring, but it's in a little of a different form. We're hoping that that full b minus 4 cancels as one of the factors. So here we go. Let's see what's left over. Make sure you keep writing limit. So in the numerator, that looks like a nice little quadratic that we want to think about factoring. So I'm going to kind of go quickly through the factoring because I'm thinking it's got to be 2b times b and b minus 4. So however you want to deal with that factoring, if you want to go off to the side and do your own scratch work, fine. But what we're expecting is one of these factors should be b minus 4. That's what I'm expecting. So I'm thinking because one of them has to be 2b, the other one, that's got to be the b minus 4. Now let's just confirm that. We need to make sure that it multiplies to 12. So 4 times 3. And so now kind of just guess and check in my mind right here, that 2b times the negative 4 would be negative 8b plus 3b. Yep, that adds up to negative 5b, and then the back numbers multiply to negative 12. So yes, it factored like that. So again, however you like to do your factoring, you can go off to the side and use whatever technique you want. But my little hint there is I knew that one of the factors, if we're doing this right, has to be the same as that denominator, which then allows you to cancel it. Okay, so a similar hope that we can cancel the divide by 0 problem. Okay, so now we say the limit as b goes to 4 of just the 2b plus 3. Now that the divide by 0 problem is gone, we can just go with direct substitution in this polynomial. And so b goes to 4, so we can go 2 times 4 plus 3, which gives us 8 plus 3, which is 11. Okay, so either formula gives us the same answer, and it's kind of just your own preference of which one you like better. I like the first one better because that's just the one that I've been using like my whole life, but hey, here's an alternative form that does the same thing. Okay, so that finishes off section 3.3. Hope you have a good day.